close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Finding life along the way, melodies we haven't played. No, I don't want no rest. Echoing around these walls, fighting to create a song. I don't wanna miss a beat. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go.
Check. Hey, good evening, everyone. Yeah, just making sure. I got a mic stand recently, so Just wanted to make sure that the mic was working. I got it all hooked up today, so it's good because now hopefully you don't hear as much keyboard. I mean, it's still right above the keyboard, but before I had it on a mic stand and it was behind the keyboard. So along with hearing my voice, you probably heard every click and every key. So how's everyone doing? We had a pretty good day today with the Cisco DevNet Create event. For those that attended the Americas session, I thought it was very, very well planned. I mean, as always, very well planned, great transitions and great sessions. I mean, they touched on, I just like the fact that Cisco goes outside of Cisco's realm per se, and really dives into the software development and tools that are out there. So yeah, I hope, if you haven't had a chance to check it out, I know that they have some different streams depending on time zones. But just wanted to put that out there. If you haven't, Cisco DevNet Create, it's a event held by Cisco. It's about every year around this time in October. Free virtual event. It's awesome. You get to see demos. You get to see talk about different things upcoming within the Cisco DevNet program. So as you guys know, last week we talked about the DevNet Expert certification, which obviously I was pretty hyped about. That was officially, quote unquote, officially announced today. So yeah, I mean, May 2nd, 2022 will be the first available practical lab session that you can book. So exciting stuff. But yeah, Day 2 is tomorrow. It's a 2-day event, so if you're interested, I would highly recommend you join. I don't know I know there's a free registration process. I'm sure you could check it out, and I'm sure you could still register to view the events for tomorrow. But just wanted to give a quick shout out because that's how I spent most of my day. Attending sessions, learning about new technologies, learning about not even new technologies per se as much as new tools to add to the tool set, especially as we start looking deeper into software development. So yeah, just wanted to put that out there. So tonight we are going to, let me pull up my to-do list. Right, so I got a little bit of a head start. I actually had some time to work on these 2 high priority tasks that we have here at the top related to adding validation job results to the database, and then adding making sure the results are showing up as an endpoint, as an API endpoint. So had a little bit of a start with the job results, saving it to the database. I left off with a couple comments. So I kind of just went through them and vetted it out before the stream, so that way we could continue diving into the code. One quick note: I added another kind of to-do item related to adding unit testing. So we haven't really touched on unit testing, but essentially code can be tested in kind of 2 different ways: your unit tests and integration tests. So unit tests are testing a specific piece of code. So think of it as like a function. So let's say you have a function that all it does is add numbers, right? So a unit test would be, and we call the function add. So we would take the function named add, and we would feed it in 2 numbers, and the result would be the sum of the 2 numbers, right? So let's say we do add, feed in 2 and 2, right, as the 2 numbers. Maybe I'll just do 3 and 3. Feed in 3 and 3. So you expect the return result to be 6 in that situation. 3 and 3, 3 plus 3. So we would write a unit test to ensure that that function does what it's supposed to do. So you would basically put in 2 parameters that the expected result of. And the importance of that is, as our application grows, we might be manipulating different parts of the program and using that function somewhere else in the program, and we may screw it up. So that's where unit testing comes in, is to ensure that if we do screw it up, our unit test will point out, hey, your add function is now multiplying. So that was a very basic example of that. Integration testing is a little more in depth, where you actually take that function and say, okay, well, how does that integrate into the rest of our application? So as you can imagine, that's a little more complicated, but specifically what we're going to be looking at is adding more, I call it add more robust unit tests, but I really need to think of just better things to test against the functions that I have. And I do have some unit tests built out, and we'll actually take a look at that tonight as well. But just wanted to give a little preface to unit testing, integration testing, and ultimately code testing. So I didn't commit the changes that I made today. I had it was just this one I made. I accidentally imported OS twice, so that's what this one's for. But since the last stream, I actually dug into a little bit. So let's see. There's a couple things here. So I actually deleted a folder, which it shows as just deleting a file, but I deleted a folder named schema. So I think I talked about this before on one of the first streams. I'm using Sql Model, the Python library Sql Model, and where we can define a data model and a table and a database table model within the same model. And I know I'm sure that's confusing if you're just joining the stream, but essentially you can model data as a Python class, and which helps validate your input, and it helps with the verification that, let's say you want to have a data model of a car. So every car has a manufacturer and a model and a year associated with it, right? So you would want to say, okay, the manufacturer is going to be a string, a data type string. Your year and model, I guess your year would definitely be a number or an integer, but your model could be, probably a string, because it could be a mix of characters. It could be numbers and letters. But anyways, what I'm trying to get to is, if you plug in and say, I want a car return from this API, you would want to make sure that, for example, the year isn't a float or a string. And it could be a string, I guess. So, and I don't want to go down the rabbit hole, but the idea is you create a model of what type of data you're expecting, and then it helps validate. And you can use different libraries. So, for example, in my case, Sql Model was created by the same person that created Fast API, and under the hood they use a library called pydantic, which helps with that data validation piece. So this SQL Model library helps you can create that data model, and then on top of it, you can actually, just by feeding an extra parameter, allow it to validate what a database table would look like. Because in the same way, what we just discussed, database fields and columns, the fields, they have to have a certain data type associated with them, right? So that's where you can use data modeling as well. So that's why, all in all, just to say that I deleted this schema folder, which ultimately I only had one file in it anyways, called init. So that's why you see that deleted. Let me see what else we did here. I don't want to go I'll jump to the make file. I'll do that last. All right. All right. So this is all the dummy data that gets fed into the SQLite database whenever we start up the application. So as I mentioned before, I just like having dummy data in there, so that way if there's, if I want to test the API, or if I just need to quickly, just see the structure of the database, I at least have some, like a reference point basically. And you can see here, it actually follows the test results data model, right? So that's why you see test results here, just to kind of wrap up the modeling discussion. So the only thing I had to do was I realized that failure rate didn't come from the results.json file that pyTest produces in its archives. And I could have calculated the failure rate, but I felt what I wanted to do was get exact data points from the results file. So instead, which was actually another data point we were looking at anyways in the last stream, was the total number of tests. So obviously, number of tests passed, number of tests failed should equal your total tests. But I figure it might be a good reference point, and ultimately this data model gets passed to the API, and then it also gets passed to the web front end for the user to view. So let's see what else. Oh, just made a comment. Yeah, used to create dummy records. So I have these functions here that actually encompass all of this dummy data that's being written to the database. So I just made a comment. All right, this is where it gets a little interesting. So this is under the post validate form. So this is after you click submit. And let me actually, while we're here, I'm just gonna boot up the application real quick. Right. Oh, and here's a good example. This is all the dummy data being fed in. And all right. So you fill out this circuit upgrade form here. Pretty minimalistic form. When you press submit, you do what's essentially a post request. Going back to your HTTP verbs, right? You got get, put, post, patch, delete. This does a post request when you click submit. So that's where this comes from, this function. So you see, it goes down through, collects all the form data, generates a test bed. Let me see if I can expand that a little bit. Yeah, let me do that. Expand that. Didn't realize it. Move OBS a little bit. Cool. All right. Got it. All right. Sorry, I just wanted to get a little more screen real estate since we'll be looking at side-by-sides. So this was on our to-do list, was adding these tests to our database, right? So we went through last couple streams of, okay, we generate the test bed based on what the user inputs into the form. We run the job. We then collect the job results and then parse out the specific data points we're looking for within that results.json file that's found in the pyATS archives, right? And so before, all we did was return those five, and I'm looking here on the left, I'm sorry. I'm going to try to highlight a little more because it might be tough to see my cursor on stream. So what we were doing before was we were just feeding those values directly to the HTML template, the Jinja 2 template. Well, on top of feeding the values to the HTML form, we also wanted to save those results to the database. And the point of that is so that way our API can fetch those results, right? Ultimately we don't want, and we really can't store everything just in memory. You can't just assign variables and keep all this data in memory, especially if you want, we want this application be running, and just a long-standing web app. So anyways, so what this, and I'm flipping over here to the right side now, what I added was just a simple way to add these results, and I'm just highlighting here the results summary, which essentially is a data model. We're adding that to the database, the SQLite database, and I'll jump over to another console, a terminal, to actually show you that. So kind of the add, kind of stages the results. The commit method here saves the results to the database, and then refresh. That kind of just, imagine like you save, the database is updated, but you kind of have to refresh to get the latest results. I'm not necessarily doing anything. I guess I'm using it down here in the actual HTML results, which is why I had to refresh. But when I was building this out, I had an issue where I wasn't using the refresh method. I was only doing add commit and then moving on, and I kept getting an error saying, "Hey, use the refresh." So that's why it's there as well. So yeah, so we refresh and say, all right, well, let's get the latest. The results we just pushed in, let's refresh. Let's get the latest instance of the database. And we go through, we convert. So this may be just a patch job, and I just don't know enough yet. But I know that to use variables on a Jinja 2 template, you can pass them in individually or with a dictionary. So what I did was I actually converted that model to a dictionary, the values from that model to a dictionary, and then pass them to the HTML form. So, and I just assign those to a separate variable to avoid confusion. But let's jump in real quick to the validation piece. Actually, we'll get to it in a second. Let me jump to the models real quick. We're actually done with this one. Right, so you'll see the only thing I did, which I mentioned in the beginning, was I removed failure rate and added in a total number of tests to it. And this is an example, by the way, of the data model right here. So it's pretty straightforward. You name, the name of the class is the name of essentially the data model. It inherits from Sql Model, which is, like I said, the kind of that base library we're using. And then here are basically what I would call the attributes of the data model. So you have your name of the test, which honestly I probably should change that to like test name, but name of the test, when it was executed, the success rate, the total number of tests, the tests that passed, the number of tests that failed. And then I just through a little bit of Googling and little Stack Overflow search, I was able to find this iter method. And one thing I found from that was basically it allows you to return an iterative value. And so that's kind of where I could convert it to a dictionary by using this method here. And so you'll see it kind of iterates through, assigns name to self.name. And self.name refers back to the data model that we just spoke. So you can see like how it kind of makes sense here. So hopefully that was a decent explanation of that to everyone watching. All right, and then lastly, let me think with the validation. So this validation.py, remember, I put it in a folder called helpers because I kind of dubbed it my helper functions, basically functions that will help me do repeatable actions. So things that we're going to be doing a lot of. So, generating a test bed, running the pyATS job, getting the pyATS results, and then parsing the results. And so you'll see when we last left off was we had a lot to do with the parsing of the results. So originally, and I'm looking here on the left here, and I know it's hard to read, but we wanted to parse out the name of the test from the results.json file and add it to the results. We needed to add the date time to the parse results, and we also wanted to parse out the failure rate. But as I mentioned, the failure rate really isn't captured, so we just swapped that out for total number of tests. All right, let me jump down here. So we did that. We parsed out the test name, and actually I found it was pretty neat. And I'll run a test and show you guys the results.json file, the amount of data there is. And it's kind of neat since we figured out a way to temporarily store those results.json file and then parse out the data points we need. It really allows us to build on this. So if we have more data points that we want to collect, using the DQ module, we'll be able to parse through, convert that JSON file to a Python dictionary and then search through it for the data points we're looking for. So it's pretty neat. But anyways, we were able to find the test name and the execution time. I didn't do any sort of fancy, anything fancy with the DQ module, since it was pretty straightforward. I just dug through the nested dictionary to find the start time of the job. So it records basically the date time, same format as you would find with the datetime module in Python. So found the date time and then obviously the name of the job. And then just added these variables down here to the parse results. And I call it parse results, but you can see here I'm using the test results data model to, like I said, it goes in and it will validate what the what we're looking for. So you can actually see, I'm sorry I kind of froze up there, because, well, let me see if you can. Yeah, you can see it on stream. You can see the class test results, and it'll tell you what it's expecting. So you can see name, it's expecting a string. Executed at, it's expecting a date time. Success rate is float, and then the number of tests for pass, failed, and total are all integers. So it kind of helps with that too, because what this would do if, let's say, I passed in the test name and I accidentally parsed out the wrong value, and instead of report name, I did report number, whatever, it's an integer. And I tried assigning it to the name value, then it would throw an error, because it would say, sorry, test results was actually expecting a string for a name and not an integer. So, and I also felt it was cleaner to do it with the data model, because otherwise you're basically, on the left side here, I was building a dictionary. Parse results was just an empty dictionary, which you can see up here. And I was just updating it with all the results. So obviously, it works, but down the line that could cause some potential issues. That could cause, what if we fed it the wrong, going back to that example, fed it the wrong value, which had the wrong data type. And so that was, I think, a good quality of life update there. So let's see what else. Okay, so I just added a type hint to say that read device logs function was returning a string, which it is. It's just reading from a text file and returning that text that is being stored in memory. And then the last, I think, bit is I just changed the type hint to say that this parse pyATS results is returning test results instead of a dictionary, which is true. So those are some of the updates that were made. And then obviously I had to import the test results data model to actually use it within the script. So that was it for that. If anyone has any questions, there's a few people in here. If you guys have any questions on Twitch or YouTube, please put it in the chat. And, obviously we could talk about it, or I could respond to it. So yeah, any questions with any of that, please put it in the chat. So I'm going to jump to before I commit those changes, I'm actually going to jump to the test. So I mentioned this at the beginning of the stream. We had some tests, or my goal is to add some more what I call robust unit testing. And you can see here, I added one additional test. So the idea of, like I said, the unit test, it's testing just chunks of code. So this one, I have 2 test files, and I'll just pull them up real quick. And you can see here along the left, it's just under a folder called test, we have test underscore backend and test underscore frontend. Pretty generic names, I know, but hey, it works for me for now. There may be a time where this grows and I may have to split these tests up even more, but just wanted to, whatever made sense at this moment. So the tests for the backend are actually for the API. So these are just testing the API. So what you see here, pretty simple. So what it does is it will create, I guess let me start at the top. Fast API has this test client built into its library, and the test client actually allows you to stage kind of GET requests, and it's very much like if you're used to the request library, it's very much the same thing. It's just included with the Fast API library. So so we'll just jump to the actual test. So each test basically tests a specific endpoint in the API. So, if we jump to the docs real quick, just jump over here. So we jump over to the docs here. You can ignore the default here. These are actually my HTML forms. I don't know why they're showing up. This is kind of a bug per se. I got to figure out how to get these off of the documentation. But essentially we have 3 main, 3 being used. This batfish one is kind of just, and I'll just show you real quick. It's kind of, it's just a dummy variable here. I just have that typed out within the API documentation. So you can ignore batfish as well. So I basically have these 3, including the root. So and the root being the actual root of the application, which in testing in this dev environment's localhost port 8000. So where we test the root endpoint, and then we also test these 3 endpoints as well. And each of these, by the way, I like to explain things as I go, so that way I'm not assuming anything. So these are each endpoints for the API. So obviously this one gets all the test results in the database, and because I had those dummy variables loaded in the beginning, you can see here these are all the the records that are ran, and that's kind of why I'm trying to get all the test results into the database, because what this allows me to do is pull the results from the database and then return it in a JSON schema. So that way, ultimately, why this API is being developed, with feature parity with the web front end, is so that way you could run these tests and you could use them or feed them into your own tool. So that way it allows some more flexibility. So this API endpoint does all the tests. This one's pretty straightforward. It gets all the tests based on a specific test ID. So if I pull this back up, you'll see that every single test has a test ID, and it auto increments. So, I don't know how many tests are in here right now. 65. So you could basically do 1 through 65, and it will pull just one test result. And then lastly, there's an endpoint to delete a test. So if you want to delete a test out of the database, you could do that as well. So, all right. So that was the the API. And so the reason I pulled that up and wanted to just show you that was because, let me just actually, there's no point in showing a side-by-side if I haven't showed you the file in the first place. So I'll just pull that away. So you'll see we have a test for the root, which is literally just slash. And then here are all the endpoints. So, it's in the API documentation, the path, the resource path here. So API v1, pyATS, that's basically the root. And then everything's under tests. Let me pull that out. Yeah. So you'll see test. And then all I'm doing here is just the first record, right? The first test recorded in the database. You could, and when I talk about robust, this is kind of where I need to, or what I want to do, is add some parameterization. So basically what that allows us to do is feed in, a host of numbers. So not just look for test one, because what if test one didn't exist for whatever? Let's say we deleted that test, or we skipped just using the test ID one, then all these two tests would fail, right? So that's where I would utilize pytest. I was going to say pyATS, but pytest, which allows us to do unit testing, and feed in some parameters and make it, like I mentioned, a little more robust. So so that's the actual tests that are being ran. As you could tell, it's pretty pitiful, but the only actual test that or confirmation that I'm doing is making sure that when I do a GET request to these API endpoints, I get a status code 200. And basically what that means is, okay, you're good. That's your HTTP status codes. So pretty, for an API, and like I said, this is just my first round of tests, so I want to build on this, and but I just figure I'd share that with you. The front end is a little neater, and so I'm jumping to that now. The front end here, I'm actually testing the HTML pages, so the web UI, and I'm going to pull them up. So, we're at home now. Validation, you see /validation up here, analysis, and about, which obviously they don't have anything on them right now. But they're still endpoints and still routable for my app. So what tests I'm running, they're pretty much the same across the board. So you can see here kind of the same effect. We're using that test client that's built into Fast API. We're doing a GET request to root, to about, validation, and analysis. And we're doing a couple different checks here. And I don't think I mentioned it, but assert basically says it's, just what you would think. You're asserting that a specific value should equal another value, right? This is your assumption. Think of assert as this is your expected, your assumption at the end of the test. So right now I'm doing a lot of, I guess you can say positive tests, which basically mean I'm looking for a good value per se. I'm making sure that the page loads with a status code 200, which means it does load. But there are ways and tests that I should write where we test to make sure something doesn't work, right? So what I could test is client.post to the about page. No one should be able to actually write or try to do a post request to the about page, and it shouldn't work. So the status code, would equal. Actually, it really depends, because it could be the method's not allowed. It could be a multitude of status codes. But anyways, I could just say simply request status code doesn't equal 200. So that way it can equal anything else but 200. That kind of leaves it more open, but just wanted to throw it out there that you could test things to make sure they don't work. All right. So I think that's it as far as that. The test front, I just wanted to go over both files since we had them open. The test backend, like I said, all I did was add another test for the delete result endpoint. But that's about it. Let me see here. Just making sure. Sorry, there was this file wasn't saved, so that's why I'm taking a second. All right. I think we're good. Oh, lastly, just one little thing. So I created a make file. So I purposely haven't brought up any of my unit testing in the past because it didn't work. So you can imagine there's not much to talk about when it doesn't work, right? So that's why I haven't brought it up. But just recently I figured out how to get it to work. And the issue was, just to explain it at kind of high level, so the root of my directory here, you see the netcheck, the actual the application is all within this netcheck folder, right? But my tests sit also on the root in a test folder. I had an issue where I tried running and you can run pytest directly from the root. And let me actually see. Actually, I think I can do this, and it'll actually make more sense. So you can run pytest, just the command pytest from the root of your application directory. And what it does is it'll look for a test folder. It'll look for files that begin with test underscore. And I believe it'll also look for the test folder. I'm not certain on that though. And so if I run pytest, and this is going to throw an error, but okay, I was worried there for a sec because if it didn't throw an error, then I would have did that for nothing. But yeah, so yeah, the error I was receiving was the module not found error, and the reason behind that was, so it goes through and it combs through the files. So, for example, my tests all refer to that main.py, right? And let me find it real quick. Yeah, so all the tests refer to endpoints that are defined in main.py, right? So all the routes and stuff. So it comes through that, and let me just get back to that make file. And so from its perspective, it can't find some of these modules that I'm referring to in main.py because it's not in the application folder netcheck. I hope that makes sense. So, main.py is within the netcheck folder, and main.py can refer to this API router that's located in the API folder in this module. And you could just kind of drill down, and I have it highlighted here. Hopefully it's readable, but api.api_v1.api. Yeah, that's a mouthful. But so you have api_v1, and then the API module here, right? So to main.py, you can refer to API relative to the actual file. The problem is when you're in this test folder here, this test file has no idea where the API folder is, because it first has to go into the netcheck folder, which then at that point, if you tried changing, you're in like a teeter-totter situation. If you change the reference in your tests, if you change all your references in your tests or for your tests, then your program breaks, and then vice versa. So obviously, I had to Google it. It seemed like it was a very common issue for people that put their test outside of their application, their main app folder. A lot of people just put the test within their app folder, and it kind of resolves the problem. But I wanted to keep these outside the application folder. So I made a makefile because what I found was all I had to do was change the environment variable for Python path and just move it into the netcheck, the actual application folder. So if you run this command, just run it here. If you run this command and change that Python path to netcheck, and then it runs pytest, you'll see my tests went through and 8 passed. So that's good. The reason it says the 50% is because there's some other endpoints that, like I showed you before, for whatever reason, the API is showing there is more endpoints than there are. It's showing the HTML pages in the front end or those front end routes as, in the API documentation. So there's just some issues with that. But ultimately, all my tests passed. Everything basically just got status code 200, which, like I said, it's pretty basic. But, for just really, this is my first bigger project that I'm writing unit tests for. So I figured just to start easy, and then we'll kind of grow as the application grows. So that's that test-driven development. And so I'm supposed to actually be writing these tests before I develop, but it's chicken before the egg. It's kind of tough. So anyways, so instead of running that command, I actually created what's called a make file, and what this does is it's a list of commands, basically shell commands that initially in the past it was used with C and some other programming languages to make or compile files. And that way, you run a make file and it would slowly compile all the different files and folders. But in my case, all I'm trying to do is run some shell commands. So this is definitely a Band-Aid patch. There's going to be more I do with this, and creating test environments and doing some more things with packaging and setup. So that's kind of down the line. But for right now, this make file works. And the only thing I have to do to run this make file is just type make. And you'll see here, maybe. Interesting. All right. Well, it looks like the test actually failed. Interesting. Oh, see, right. This is like kind of my point, because I haven't had these fail before, so obviously they would fail first on stream. But so this is like but this is like a good example though. This is actually something I don't mind kind of going through, because you see here we created a to get the test results, get test result test ID number 1. And so I said, in the test it says, okay, assert that the status code equals 200. Well, here it shows actually we got a 404, which is saying not found. So the test failed. You see the assertion error right here. So that's great. That shows my tests are working. Now to figure out why or what happened. So that was for the get endpoint. So that was just getting test ID number 1. And then obviously the delete endpoint failed as well, or the delete test failed because test number 1, if you can't get test number 1, obviously you can't delete it. And that had a little more verbose of an error message. So yeah, no result found. So cool. Perfect though, right? And you can see there is a, I just went through all the error messages, but you can see here the short test summary. You can see it says that the one test result, the assert 404 doesn't equal 200. And then when you try deleting the test SQL Alchemy, which actually sits right underneath of SQL Model, what I talked about in the beginning of the stream, is built on SQL Alchemy. And you see that no result SQL Alchemy said, hey, there's no result found for test ID number 1. So very cool. Actually, like I said, I'm glad that the unit tests actually didn't work. So that way we make sure that our testing those assertions actually do work. So let me see here. Database. Let's just delete that. So I'm going to commit these real quick. What did we say we did? Let's see. So added validate results to DB. So yeah, added validation results to database. Done. Just did a commit, and then I'll be pushing these results up to the netcheck repo, which I have, or I've sent that out. I've tweeted that out, my GitHub that has this repository. So, and all these changes are happening on master branch, which technically isn't right. But since, I'm pretty much the only maintainer at this point, kind of just doing it as is. But if there's some, larger feature, there's a good chance that I'll be creating a branch just for that. So for example, when we begin integrating Batfish, I'll be definitely creating a branch for that and then merging it in. So, okay. All right. So, and actually I committed it. I don't want to check it off just yet. Let me actually pull up. Let me pull up the database. So what I'll do is I'll run a test. So I'm connected to my Google Cloud EVE G environment, and so I have my environment here, and I've only really messed with this one router. So I only turned this one router on, which, so be it. All right, so it's up, and I already made sure I could ping this before, but hold on. Just reboot the server. Okay. There we go. All right, so remember the host name we actually are learning, so that's kind of for logging purposes, but we'll choose the device OS. So just to show you, I basically have iOS XE, iOS, and then ASA it's white because it's disabled, but sooner or later we'll put in an ASA, because I know some people, they use that as an edge device as well. Plugging a circuit directly into an ASA. So, all right, and then we'll put the address, and we'll press submit. So you see it's loading now. When I press submit, that's where going back to main, that's where this post validate form that kicks off here. And you'll see down here the pyATS job is kicking off. And the other thing I was thinking about doing was in the test bed, you can do this a few ways, but by default, pyATS has a timeout or a connection timeout, where basically it just sleeps for 10 seconds before it actually disconnects from the device, which inherently it kind of it seems like it's running slow, but it actually has kind of a sleep timer. Oh shoot. All right, let me run that one more time, because I actually wanted to show you the I wanted to show you the results.json file. Just to show you, like I said, all the data points that we can pull. So it's kicking off here. It's kind of going through. Actually, oh. I actually meant to start this at the beginning of the stream. So I was thinking, because we're just coding and it can get kind of, I'm sure my voice is so soothing to where, you know, you fall asleep. It's pretty boring, honestly, probably, unless, you know, some error gets thrown or something like that. But I was thinking about playing some non-copyright music. So I actually found, just through some Googling, that there's a YouTube channel called No Copyright Sounds. And they have a SoundCloud playlist and some other, a Spotify playlist. So I was actually just going to play some of that in the background. Hopefully it's not too loud, though. Hold on. Let me make sure desktop audio is a little lower. So I guess whenever I'm going to kick it on here. Let's see. Let's play this. So I'm going to start with just the intro song. Actually, no. We listen to that too much. Alright. I have no idea. I have no idea about the music we're listening to be honest. But I figured, you know, it changed things up a bit. So, yeah, if you could, just let me know how the volume is. I see it's definitely lower than my voice. If you want me to turn it up, I can do that too. But I figured just to have it in the background as we kind of go through here. So, what was I even going to show you? Oh, yeah. Just pull it up. Alright. Let's see. Alright, so what I'm going to do is show you the contents of this database.db file. And so that way you can see those test results are being saved now. So let me just show you the tables just so, never mind. Oh. Exit. Alright, let me try this again. Alright, there we go. I forgot I had to actually pull up the name the database. Sql Lite 3. Alright, so what I'm doing now is, as you know, I mentioned this before, just to quickly highlight the database.db file that's in my application directory. It's a SQLite 3 database. It's the simplest form of a database you could get. Other databases, you actually have to set it up and connect to it. This literally is a file. So I can use this SQLite 3 CLI, this command, to access the database and then run SQL commands against it. So just to, you know, at a high level, just explain as I go. So there's only one table called test results, and we do select star from test results. So you'll see there's a bunch of data. And a lot of this came from the dummy data. So you'll see like L2 STP check, like that's not a real test we're running. So, and you can see the kind of repeating pattern. But anyways, there's a circuit underscore job file. That's a legitimate result. And just to get more familiar or get more specific, And this is just showing off my amazing SQL skills. So what I'm doing here is I'm saying select everything from this test results table where the name is equal to circuit job file. All right, and you'll see, actually, just to break it up a bit. So you'll see here, I've ran it a few times today, right? I actually ran this right before the DevNet Create event started this morning. But you'll see I also just ran it twice, 2051, yeah, so it's 2057 right now. And I'll run it one more time just to kind of show you that it is what it, not lying. So this was about 5 minutes ago. So right now it's 8:58. So it should show up as about 2058 or 2059. But let's just run a test real quick. Yeah, like I said before, the music, hopefully it's just a change of pace. It's kind of just a randomized playlist, so I don't know what's going to be played. I think a lot of it's like EDM music, but I figure it's just some white noise in the background. But if you do like any of the songs, the YouTube channel is called No Copyright Sounds. And they have all of these songs hosted on there. It's actually pretty neat. I kind of found them as I was Googling, like, what to stream, what you can stream. Obviously, you can't stream Taylor Swift or any of the big record labels. So, okay. So this test finished. You'll see here in the application logs that we're good. SQLite. Boom. That last record there, right? Shows our date time, shows the success rate, total number of tests, total success or test passes, and then total tests that failed. And then this 74 is that test ID I talked about, where, kind of that unique value, or what you could call a primary key in a database, right? It's what differentiates each record. And the name of the name of the job was circuit job file. This can change depending on the job. So the idea, right, behind all of this, and just before I jump or get off this page, all those file or all those data points that I talked about at the beginning of the stream that we parsed out and that's being passed to the HTML template, the Jinja 2 template, are all being used in the template. So you'll see the success rate here, the total number of tests, the total number of passes, and then the total number of failures. I didn't put like the name of the test or the date time. That's more or less for the API. And so, but I wanted to include it in the model. And there is a chance maybe down the line that we would include that information. It's just, I don't need to show everything. So, all right. Oh man, we got a saxophone? Not bad. All right, so yeah, wanted to show you that. I'm trying to think what. Oh, the results.json file. So you'll see here. Normally these temp folders here, temp_results, temp_testbed, are deleted. These are created whenever we go and actually run a job, a pyTest job. So I still create the YAML file. I know others out there like John, his Merlin project, he actually creates this from his database. So he actually has a database where he stores his devices and a table that stores all of these values as basically columns, from what I remember from the last stream we had. So, but I wanted to just keep the YAML format. It's honestly not too bad. I'm creating a test bed and then deleting it after every job, but it can get better, right? So I figure this is what I'm most comfortable with, and then down the line I can change things up if I need to. But so we create this testbed YAML file, and obviously that gets deleted, but the real reason I wanted to show you this was the results.json file. Yeah, look how fun this would be, right? Imagine reading all this text. Yeah, no shot. So you can actually right click and format document, and boom, now it's a little easier to read. So we'll go through this data in a second, but this all comes out of the box, right? So my first idea, just, I'm gonna spitball and talk out loud for a sec. My first idea was, okay, I can run this in standalone execution, and what that is it allows us to, everything basically gets printed to the standard output or the terminal, right? So I was like, okay, I could do regex and regex that standard output, right? Or I could redirect it to a text file and then regex. And then I was like, that could get messy real quick. I mean, what if there's multiple data points I want to pull, and then how do I keep track of all of it and everything like that? Let me just turn this down just a hair. Let's see. Actually, we'll just keep it right there. So anyways, so I was like, all right, well, man, regex is gonna suck, pulling all that. So instead, what I ran it using the EasyPy execution harness, and I found out that it archived, it basically runs the tests. You can manipulate it via, during runtime. So if you need to change files up, or pass in different parameters, or just change things up, you can. And just to show you, I save all the archives, and probably about time to delete this, but I do have this pyATS _logs folder that will get created on your, like if you were to clone this gets created. It doesn't get tracked via Git, so that way, obviously we don't need all this stored in GitHub, or even, you don't really care about it. I don't, it doesn't bother me. So, but I wanted to keep it here just for archiving purposes. So that way, if there is someone out there that says, you know what, I actually do care about all these archived files, then you could keep this as long as you want, right? Yeah, as long as you have storage available, you can keep this folder with all these archive zip folders. Now I will say I don't care about it for testing right now, but I will say it does unlock a few things. We can definitely run some additional testing, some regression testing, right? So you could actually compare some data that was found, let's say back on October 4th, with something that we just ran, 10 minutes ago, right? And so it could be, you could definitely extend this to something very meaningful, but just for where we're at in the project, I just don't have, there's no purpose of using the zip folders or the archive files just yet, besides the results.json I'm referring to. But yeah, but they're there. They will be there. They don't get deleted. So under temp results, a folder does get deleted. There's normally 2 files, but because we didn't delete it in our last run for me to show you, there's a log file which collects all the show run information, or I should say all the CLI information. I call it show run, but all the CLI information, anything that you would, you SSH to a network device and that comes up in your terminal, that's what this log file collects. And so I'm just scrolling to the bottom. Yeah, show versions there, the pink results, everything, the logs. So all this is captured. And that's actually what's printed out right here in this detailed results tab, or box. That's what's printed out here, and you can actually download it. Allows you to download it, and it has the date, time, the IP address of the device, and then dash results. So you can save this text file and attach it to, you know, a change ticket, whatever you're planning on using this application for. All right, so we're moving on from that. Now to actually get to what I wanted to talk about. So yeah, this came formatted as JSON file. As you know, if you're familiar with Python, you know that JSON and Python can talk to one another pretty easily. It's very easy to convert this to a Python dictionary and interact with it at that level. Once it's in a Python dictionary, you can use the DQ module found in the Genie library, or dictionary query module. And what that allows you to do is basically slim this big dictionary down, or all this data, right? Because if you think about it, I mean, look how much data there is. And this goes into every little detail, every test. Like you can see here, I don't want to move it. Checking the iOS version, right? It tells you start and stop time. It shows you how long it took to run. I mean, that's less than a second. Tells you the results, it passed, and then the reason it passed. And all this was coded, that I coded in the test file. So as you can see, there's a bunch of data points. All you have to do is convert it to a dictionary and kind of interact, find the data points you want. So that was the big reason of creating this whole like temp system, I guess you could call it, this temporary system where like you create the temp folders and you know, store the files there and then delete them at the end. So that way we have access to all this data. So anyways, so for my models, I was collecting the basically everything under the summary here. So here's your total number of tests, here's your success rate, here's your number of failed, and here's your number of passed. The only other things I was collecting were actually from right underneath the report key, and that is your name. So the name of the test, or the, you know, the test suite, or what they call the test suite, which is circuit job file, hence why you see circuit job file down here in the database, because we're literally just parsing out this name and then putting that into the test results data model and then storing that into the SQLite database. And the only other thing I'm saving is the start time. So this value here, which you can see right here, down to the, man, I can't get down that, way past the nanosecond. I mean, that's what, 6 decimal places back. So it's pretty exact. And that may be something I actually have to change in the future, to be honest. Especially if I ever use the date time to do comparisons. It'll be kind of tough to get down to, you know, the 6th decimal place. So anyways, that's just how I'm storing it for right now, because that's the data is provided. The other neat value that I thought about adding, but I may create another data model for, is performance. So this value here, runtime, is actually how long it took the entire test to run, which you can see is about 23.5 seconds. So that's really neat, because at that point you can say, okay, I want to get the test results for test ID 74, or get test ID for this date, you know, 10/19/2021, and I also want to see just only the runtime of all those, right? So that'd be kind of neat to add. That may be something we add, and what I'll do is add it just to what we'll do is say add runtime to just make sure. let's just put a priority on it. We'll just throw like priority 3 because it's really not huge, but anyways. All right, so we saved. So the test results are saved. Let me just pull this Todoist back over. Test results are saved. So I think it's about time we check that off. Sweet. All right. So one of our high priority tasks are done. Now we can add validation job results endpoint to API. So I'm trying to think of when I wrote this, what I was trying to say by it. Add validation job results to endpoint. A results endpoint. So I'm trying to think. I'm trying to guess because right, because we just went over the endpoint. So we just went over the pyATS endpoints. And if you get the test results, oh, I think this referred to, I had to change the data model. Remember I talked about the failure rate not being included in that results.json, and I wanted just to pull exact data points out of there. I think that was my problem. So if we go down here, okay. So the test results are being pulled because you can see here the one that was ran at 858 was pulled. Success rate, total tests, all that stuff's being pulled. So I think what I was trying to, why I added that as a point was because instead of having total tests, we had a failure rate test. So yeah, so I think we're good. I think we're good with that one. Check it off. Cool. All right. I mean, that knocked out 2 then. All right. Let me see here. All right. I got about 15 minutes left, 20 minutes left. I'm going to let's dive into this unit testing because we talked about it. Some of the other things just to mention, creating another test script. So the idea behind this one would be creating this TBD would turn into another test that we would run. So that would be pretty simple. I just have to find or figure out a good test case. This one I kind of just brainstormed out of the blue, creating a layer 2 test script. So something where you might check your spanning tree, you may check switch port status, you may check, like there might be specifics, we can go into that. The only reason I was going separate was a couple common use cases for changes are circuit upgrades and switch installs, or adding a switch to a stack, right? A lot of people, that's one of the common things that when you're first starting out, network engineer, network administrator, that's what you do. Some of these tasks that they're in no way, I wouldn't say easy, because they obviously, like a circuit upgrade, if that goes wrong, that can go terribly wrong. But they're easier tasks as far as the task itself is. For a circuit upgrade, maybe change out a cable and make sure that the interface comes up and check routing and whatever routing protocol, most likely BGP. So that's kind of where the circuit upgrade test came from. And the layer 2 is mostly, like I said, for switch installs, but I got to think about that one. There's a chance that we change that. We just talked about that. The celery workers for tests. This actually I was messing around with Redis and celery, and there's a good chance I'll probably go down the same route as John did, John Capabianco with Merlin. where he basically created separate Docker containers and ran Docker containers to run those services and the workers. Because ultimately, that's what, this application will most likely become a Docker container, because a couple reasons. One, containers are just, it's kind of the way of the future. I mean, from the portability to just the size and the overall, just there's not as much baggage per se. I can, as long as you're familiar with containers, right? They're very portable. You don't have to set up your own environment or anything like that. You just pull down the Docker image and spin it up. Unless there's specific values you have to input during, turning up the containers. And on top of it will be when we get Batfish integrated. Batfish is its own container. So to interact with Batfish, you have to have a Batfish container. So it just makes sense that we would create this application would turn into a container. So yeah, anyways, the Celery and Redis, still kind of TBD. The only other thing I was looking at, and I'll just kind of make note of it. We'll just say let's say the Fast API component, run pyATS jobs asynchronously. Post results to some sort of results page. All right, just scoot that over. So, and this is going to be a lower priority one for sure. Actually, probably like a medium maybe. We pull up the priority to. Alright, I gotta figure out how to rearrange that, but so this would be, because Fast API has async functionality, and if you're not sure what async is, or running jobs asynchronously, async programming, conveniently have a blog post out just for you. If you go to devnetdan.com, my latest blog post is actually sync versus async. And basically the synchronous jobs and synchronous programming is kind of like how we have it right now, right? You saw earlier I pressed submit and it just said loading and had the little spinning bar or the spinning circle. That's great and all because it's an indicator saying, hey, yeah, we're working on this, but I can't do anything else. Or if I tried doing something else, it would basically cancel that job, right? And you could see that because we have just take these main.py. Yeah, so you can see like there's nowhere here that's like, it doesn't say, you have to reference, I have all these as async functions, so like you have to reference async, but then there's basically what that allows you to do is run jobs or run tasks and let them run without having to, run task 1, wait, okay, task 1's return, okay, let's start task 2. But that's the case here, because what we do is we wait for the job to finish, we save the database results, and we return the HTML template. Whereas ideally, I would love for a user to come to this page, have all these different, and this is the reason I kind of designed it this way, these different cards. So like I'm picturing circuit upgrade, TBD, and then maybe you scroll down, there's a couple more cards that are common changes that network engineers perform. And you could press submit and you could check one device for a circuit upgrade, and then you go to this card and say, oh yeah, I just installed a switch. Let me make sure like all the switch ports are up, or the software version is running this code. and then you press submit over here, and you have two jobs, right? Two checks going at the same time. And then I'm picturing some sort of like results tab, you know, that you would click, and then it would show a list, right, of all the different jobs and their status, whether running, done, complete, error, you know what I mean? So that's kind of like that will be a learning experience with that. So that's kind of, yeah, actually, thinking about it, it probably should be like a priority 3, because that more or less will be kind of a feature versus just what we're doing now is just making the app better. It'll make the app better, but it'll definitely change functionality. So I'll keep it down here for right now. That's a lower priority. So, all right, let's with the last 10 minutes or so, let's just jump into pytest. Pytest. So yeah, pytest, and I can tell you in all honesty, I haven't really looked through too much of this documentation. So what I'm going through now with you, if I say something wrong, there's a good chance it's because I could be wrong. So yeah, pytest, I mean, I know what it does, but you know, as we go through this, there'll be times where you might see a light bulb go off and I'll be like, oh, there's a better way to do it. So yeah, right here at the top, makes it easy to write small tests. So those unit tests I was referring to, but it can scale to functional testing, and kind of probably, you know, more towards that integration testing. So you use the assert statements. Let's just go to the getting started page, so I just don't ramble. So I already installed pytest, but I mean, here's a perfect example. Perfect. Actually, they stole my example, and I promise you I did not read this page. This function, it takes in a parameter and it adds 1. So this is a perfect a unit test to make sure this is actually one that fails purposely. So you'll see it feeds in 3. Obviously the right answer is 4, but it returns 5. And you can see here it shows an error and it says assert 4 equals 5. And funny enough, I think I already cleared it out, but that's what my test did, except it said assert 404 equals 200 because it was referring to the status code. So pretty neat. Oh, here we go. The 100% refers to the overall progress of running all test cases. After it finishes, pytest then shows a failure report. Interesting. So it ran, so my backend tests is showing 50%. So I guess there's test cases that aren't being run. Doesn't make sense. Yeah, because so when I run this, it says 50%, but it runs all these. I know it runs all these tests. I know it runs all these tests, so. Interesting. All right. Let's see. Running multiple tests. Yeah, so pytest will run all files in the form test underscore star or underscore. So basically, if you start with test underscore, start the file name with test underscore like I'm doing, you know, test underscore front end, test underscore back end, or if you end with underscore test, then it will run. It'll run those files. It'll run all the tests within those files. So, okay, so yeah, you can test that certain exceptions are raised. Group multiple tests. Request a unique temporary directory for functional tests. So that jumps into functional tests. I don't really need that as much as marking test functions with attributes. This is what I'm looking for. So I've seen this on a couple YouTube videos, and actually a few people I follow on Twitter, they use pytest to test some of their functions, network automation functions. So like, we're using to relate kind of using pyATS to run tests against the network. The pytest, what it does is it will connect to a device, or I'm sorry, the examples I've seen, connect to a device, it returns data, and then they use pytest to say, okay, I'm returning data. Is this value is what you expected in this, let's say, this dictionary, this key value. So that's another way to do it too. If you were, testing data. This helper, you can easily set metadata on your test function. So this kind of goes to changing or adding data dynamically to your testing. So like I have, which failed, I have the test ID is statically set to 1. So those tests for getting test ID, it's get test ID 1, delete test ID 1. So yeah, so I've actually seen a few with parameterizing, and what this is actually what I was looking for. It enables parameter. No shot. Basically adding all these values of arguments for a test function. So implements checking that a certain value input leads to an expected output. This is neat because what it does is, you can see here, it's checking against these pairs of values, right? So you have your test input and expected, and these are your labels. They correspond with your arguments here. So test input, expected. So my test input is 3 plus 5, and then my expected is 8. So obviously this first test here, which is in parentheses, that would test out fine. 2 plus 4 equals expected value 6. Good. 6 times 9. No. Yeah? No. So, yeah, no. Yeah, man, mathless this late. No. Even easy math. But, so anyways, but you get the idea. You have your test inputs, your expected output, and then it does an assertion. So that's actually something I probably could figure out how to do with testing not valid inputs, or I'm sorry, expected values. So, feeding it bad data and then expecting, like for example, a 404 error. Defines, 3 different tuples. Test eval functions runs 3 times using them in turn. Cool. Yeah, see, I was right. I'm not that dumb. So yeah, but you see here, it ran all the tests, the first 2 tests, and then failed on the 3rd. So parameter values are passed as is to test, no copies. Okay, pass a list or a dictionary as a parameter value, and the test code mutates it. The mutations will be reflected. Interesting. Okay. Interesting. All right, I'll have to play with this a little more. The parameterization and marking this, pyATS mark the helper here. So I might mess with this a little more. Now I'll be. Let's see. Yeah, so I'll be co-streaming again with John on Thursday. John Capobianco, and I didn't mention it early in the stream, but congratulations to him. He actually won an award at the DevNet Create event for a basically a community creator, leading the community and the charge in, establishing DevNet and being part of the community. So he does a great job, and he's done a fantastic job with Merlin. He's definitely a great guy. I loved our last co-stream, and we talk off stream as well, just about basic network automation issues. Just we try to join as many community talks as we can. So definitely well deserved. So congratulations to him. And so we'll be streaming on Thursday together again to finish adding that show license summary parser to his Merlin application. And then next Tuesday, we'll be picking this back up with most likely unit tests. We'll probably dive more into, I'll try to make some progress on these tests and see if we can make them a little more, like I said, robust, where we can add in some more parameters or multiple tests basically. And then where did my backend test go? Got to figure out some more tests for the backend, because just doing a status code, I guess with an API is great, but like maybe testing to make sure that JSON data is returned, or that JSON data with a specific key. I'll have to brainstorm a little bit about that. So yeah, I really appreciate, I see that let me see here. Yeah, see, there's a couple people still on, so I really appreciate you guys sticking around. I hope this is informative. Like I said, this is kind of me learning along the way as well. As you saw, I was reviewing the pytest documentation. May be boring, but at the same time, the struggles that you may see me go through, hopefully you can see, in your own studies or your own coding, that it's normal to spend some time in the documentation, right? Especially after seeing a lot of great presentations about, I created this tool using all these different libraries. A lot of time was spent in those libraries to learn the syntax and all the different modules within those libraries. So just stick with it. That's about it. I'm trying to think if there's anything else. I already talked about Thursday. We'll be picking this up next Tuesday. And I guess this may be a good time to mention it. So, I think last week, whenever the DevNet expert blueprint was initially released on the website, without the official, the official announcement was today. But, with the details being released last week, I mentioned on stream that I'll be definitely going after it. Probably try to be one of the first ones to get it, and definitely one of the first ones to test. So there's a good chance that within the next few weeks, I'm thinking probably beginning of November, that this stream will adjust a little more to studying for that exam. But we went over the exam topics. All of it has to do with software development, whether it's design, deployment, using tooling, like Terraform or Ansible. So it may not be, coding specifically for some, a custom tool like we're doing now, but it will definitely be, I think it'll be pretty interesting, and you'll definitely see me fall on my face more than once with those topics. So, but anyways, I appreciate everyone sticking around, and I will catch you on Thursday when we co-stream with John. All right, thanks.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left.